Hello and welcome to this outside-inside test-driven development tutorial. In this video I'm going to be going through the banking kata. The banking kata is kind of like a more real-world example that you might be given as a greenfield development project. And what we're going to be asked to do in this kata is print a statement, make withdrawals and make deposits on an account service. The account service has an interface. It's going to look a little bit something like this. This is our constraint. It's deposits with an int amount and then a date time of date, withdrawals with an amount and a date time of date, and print statement, which is void and basically has no arguments, no parameters passed in. An example here, if a client was to deposit 1,000 of a currency of your choosing on the 10th of the 1st, 2012, and another deposit of 2,000 on the 13th of the 1st, 2012, and a withdrawal of 500 on the 14th of the 1st, 2012, when they print their statement, it should look a little bit something like this, with a date running down the side here, the latest being on top, the balance being current, and the amount that was withdrawn or deposited. Okay, now that we know the requirements of this kata, let's get started, shall we? Well, first off, you know I love my Blue Peter. Here's one I did earlier, and I have created the interface of this kata, the iAccount service. Now, I will note that I am going to be making a in-memory repository. By all means, if you are daring and brave, use a real database. But for the purposes of this kata, I will be using an in-memory repository. The account service, as you can see, fits our requirements. We have the amount, we have the date time for deposit and withdraw, and we have our print statement. I haven't got anything else in here other than a presenter, and this is because it goes a little bit beyond the scope of what I'm trying to show in this video. I will basically just leave this is using a library called Spectre Console, and I'll just leave this up for you to copy when we get to that step of actually running our code and proving it all works. The only other thing, I have basically a skeleton. Oops, I actually forgot to comment this out. I have a skeleton of my intended design here for later when, again, we come to run it. And it just speeds my video up a little bit, just to demonstrate how it's all supposed to look if you were to run this in main, as you would with any program you might write like this. And yeah, that's it. That's all I have. So I am starting from scratch, pretty much. There's no tests no test classes in here. I'm starting from scratch, just like you would be. So you can follow pretty much what I'm doing at home. I'm just going to commit the program bit that I just commented out. But other than that, I'm now going to cd into banking tests and run the tests. We always run the tests to check everything works before we start anything, just like before. And you can see that we have a warning, which is we don't have any tests, but otherwise everything's absolutely fine and we're good to go. So with that being said, we need a place to start, and what better place to start than the account service. We'll call this the outside loop, because the account service is going to have a collaborator of this in-memory repository I was talking about. And it might also have another collaborator that we will need to consider. So let's start there. First thing I'm going to do is create a new file, and I'm going to call it account service should.cs. CS being the file extension, of course, for C#. Generate a namespace, generate a class using the macros for shear speed. Update the namespace. And I'm just going to basically outline a skeleton of tests. I like to do this sometimes. Again, we strictly want one passing test, like one failing, then one passing test, and then we refactor. But there's nothing wrong with skeleting out the direction you intend to go. If you have a upfront design, why not? Deposit, withdraw, and print statement. These are the three main things we want our account service to do: deposit, withdraw, and print a statement. And what I'm going to do, I simply just comment out the tests we don't care about right now to keep it strict, to keep it that one failing test, one passing test, and then our refactor step. This outside loop is going to use interaction tests. If you remember the previous video, interaction tests are the tests that check what the interactions are between our unit, account service, and its collaborators. In this case, it's going to be an account repository. So we can do some ahead of time thinking and refactoring. So we can do a constructor for our test class. We can do an account service. We can do the account service equal to a real account service. Whoops a daisy, I forgot to put new, that would help. And I don't want to create that just yet. I want to create something else first, which is this idea of an account repository, like so. Hang on a sec. Give this a real name. I'm not the best at spelling, folks, so do bear with me. We want to access this, so I'm going to move out the scope of that constructor. We are going to generate this interface, and you may have noticed in the previous video, and I didn't really talk about it, but there's nothing wrong with putting your code, your production code, in the actual test class temporarily whilst you drive it out and then move it into files. There's absolutely nothing wrong with this. You can literally consider this part of the flow and a refactor step. It keeps it kind of easy to work with. Of course, you can split your screen into halves and other things as well if you so choose to. Now this account repository mock, or this account repository testable, should I be more precise with my language, we're going to pass in as a constructor argument into our account service. This will give us a reference to that account repository that we can then use when we mock and spy and other things on it. So let's generate the class and the constructor with fields. We can go to it, and you can see everything's set up as we intended. It's two, quick actions, as it were, two suggested actions on my IDE away from, or three in this case, and we have a valid class skeleton, basically. It's really easy to do, right? And then we just need to give these some meaningful names. Any actions you take with your IDE, you can, for the most part, trust as all being fairly kosher as refactoring goes. So yeah, don't stress too much. You can drive from the tests to a certain degree, but you can have some level of autonomy. Let's make these private read-only. And then we have our given step above for our account service, but we need to see, we need our deposit to use our account repository, right? We need to ensure our account repository stores that deposit. So what we're going to do for that is we're going to create a mock, and in mock queue's case, it's a delegate that we're going to define here. So this is AR for basically a shorthand of account repository. And then in here, we can define what we want. So I'm going to give it a function called deposit. Again, remember that I like to define my when step so I can understand what I need. And what I need is an int and a date time. So in here, we can define an amount of 2, for example, and a date time. Dates equals date time now. Now it's very important that you define date time in a variable, because otherwise you'll have slightly different answers. With date time now, it will give you exactly the date time now, right? So it's very important to define that in a variable if you ever do anything with dates. And that's what I want my deposit to look like. I basically want it to take this amount and date that I pass in here, and then pass that into my deposit in my account repository to use. And then account repository, what I'm going to do with that is verify all and verify no other calls. And what this is going to do is check that this method was called, and it was called no more times than I expect. We've defined it to call once and no more than once. So that is cool. You can actually do some other stuff. You can do verify and basically let me just define this method quickly. Oops. Generate method. And now I have access to it down here. And then you just can put the same parameters in. This is a manual way of is it times time? I can't quite remember how you do this. Times dot. Yes, that's it. Times at least once. Or you can have many, not many. Sorry, you can have at least once between a certain value and a certain other value. You can have at most twice. You know, all these sorts of options that you can verify with. But in our case, we just want these two simple ones, and I think that for the most part is the best way to structure interaction tests in general. Now, I'm just going to change or just check one thing. I'm just going to switch the access from this to internal, because I just want to show you one little part to this, and I'm of course going to have to think I have to change the top accessor or something to internal as well. Yeah, so everything's happy. So imagine you had everything as internal. Now the error I'm expecting is this throw no not implemented exception, right? Now if I was to run this test, and we don't make assumptions, but we have an idea in mind of what we would like to see. When I run this test, you're going to see a different exception, a different thing being thrown, a different error. It's a system argument exception, which is not what I expect. So in order to fix that, you need to have basically the accessor as public on both parts, but specifically the interface. And everything that consumes a public interface will of course need its own accessor elevating to public. So when I run the test now, I will get the error I expect, and then I can commit. System not implemented exception, which comes from calling deposit. So we now have the actual error I expect. I can commit that. Again, remember from the previous video, we go red, commit, green, commit, refactor, commit. Sorry, I karate chopped my hand like multiple times there to really hammer home the point. So we can make this test that it's valid, pass, and to do that we can go down to deposit here, and we can do account repository dot deposit and pass amount and pass date. And if we run .NET test, we can see that because we've implemented the method, that all should be passing, and we've proven that there. So I can commit that as my passing step. Now I just want to briefly show you, if we were to put date time now here, for example, or 5, right? That if we were to run this test, what we would get is basically our mock coming back and saying, hey, dude, like the method you asked me to call doesn't match what was actually there. So this is saying I'm expecting 2 as my amount and this date, and I didn't get that. So you need to look at what you've done with that call to make it use what I've put in here. So usually it's a case that you haven't passed that information to the method in either the constructor or the parameters of the method itself. So you can see in here, of course, the amount and the date above, and basically I'm back to where I was, right? Never assume. Let's run our test. I don't know what changed, maybe a spacing or something. Let me just format. Yeah, okay, back to where we were. Okay. So we've got one passing test. Is there any refactoring work we can do? Well, you know what? If we really wanted to, we could make that an expression body and just have it firing off screen there. Run our test again. All is well, commit that. And then for the tests themselves, well, we could make this a theory. And we could add some inline data, and we could pass different amounts in and see if it works as we expect. So we aren't making assumptions that we've just put a 2 in there for it to pass the test with the simplest implementation. We can triangulate in there and ensure that we have that confidence, as I was talking about in the previous video. So if I run the tests, You'd expect 3 passing tests, but let's verify that that's what we're actually going to get. And there we go. Now we don't need to waste time as developers, and we are lazy. So let's copy this test because it's going to form more or less what withdraw is going to do. And we can change the test name, the setup call, and the unit, or the mock call, if you will, and the actual units call creates the method, and this is a valid test. We have an amount. We're passing it into withdraw. We for the account repository that we expect it to call when we call our account service withdraw, and then we're verifying it. So let's run our test. Remember, we are expecting a not implemented exception. We're going to get 3 failing tests, but we have an established pattern. So we can use our established pattern to make this 3 tests go to green very quickly. We're within our 5-minute cutoff, our 15-minute cutoff. We don't want to make our red to green step too large. It's iterative, it's small iterations that build to bigger things. System not implemented exception 3 times, I'm happy. I'm going to commit that because it's a valid test. And I'm going to now make that pass by adding our account repository, withdraw, and pass the amount down, and pass the amount down, and pass the date down. I'm then going to do the obvious refactor and save myself a RGR cycle, a red-green refactor cycle. And there we go, 6 passing tests, and commit. Just remember when you do these obvious refactors, if you have like 4,000 tests in a real life sort of proper enterprise system, it's going to take the best part of a good 2 minutes to run all those tests. Even at like 10 milliseconds a test, it's going to take a while. So if you can save yourself a cycle, do so. Last but not least, we have the print statement. Now, the print statement is going to require something else, so we can't just copy what we did like we did with withdraw. We're going to need to do something new, and we know that we're going to need access to a statement printer, like I showed you before. And we have now defined this testable, and we should use our testable. So our statement printer dot set up statement printer, and there should be a print statement on there. It might not exist. Let me just go to it. Now, our statement printer has a concept of an iBank transaction. So we're going to need to define that as well. And I'm going to define it in our models, wherever I put that, if I even have a folder called models, and I don't. So I'm going to make a new folder, call it models, and in here I'm going to define an iBank transaction. And this is the advantage of the outside-in approach. You can define these not real things and work that detail out later, basically. You can define your concretes later. So in this case, I can do that. And in theory, and then we can just do bank transactions in here. And we just need to add the using here and remove that comment out line, and all's well. So we've now got this list of this concept of iBank transaction. We don't know what we want for that yet, and we have this print statement that uses this list of bank transactions that we are expecting. And when I call account service dot print statement, I expect statement printer verify all and verify no other calls. Now, the problem with this is that we don't have any location that the bank transactions live on currently. And so we're going to need to define something new in a moment. So let's just commit this, because we have defined a new failing test that meets our expectations, right? It hits the or not, because we didn't implement it. Good. Okay. So statement printer. Let me just define a rough version of this. And of course, once we've finished this Kata, I'll just uncomment that. We don't need to worry about this not being implemented right now unless we were actually to run this. So we can actually just leave this method as it is. And we can't test it. This is the bound of our program. It's testability. It's in the UI part. So we'd need a different type of testing to test this, if we could even, if we even can. I'm not even sure we can for this. So okay, so we have this abstract implementation, and we can of course run, and it should compile at least. And we can see it's failing for the right reason. System not implemented exception. So we can commit this and be happy. Okay. How do we make this test pass? Well, we're going to need to take our account repository, and we're going to need to set up our account repository with bank transactions and return bank transactions. Now, what this is a stub. This is a stub, and this returns basically a known result when something is called. So bank transactions is going to be a property. It's going to be a list of bank transactions. And because Visual Studio is a little bit funky at times when you use the IDE to do everything, I'm going to define this manually in the interface. And making changes to the interface manually is perfectly fine, basically, in a test-driven approach. And I'm just going to do the standard. We have a new collaborator. We need to ensure that it runs its things the way we expect as well. So if we just go F12 here and F12 here, we can define a list of bank transactions, and have that as a property. Oh, sorry, it is returns plural. And that is our valid test. So I think we should commit here and then run our test. Well, maybe you would want to run your test first and then commit, to be honest, but yeah. Now you can see we still get our system not implemented exception, but we now have a design that actually stands the chance of passing the test. So if we were to do we are going to need to pass in an I statement printer into the constructor, because remember, we are constrained with our methods. We can't define our method with additional parameters. We have a fixed constraint. That's a good point. Let's make that read-only too. And as a result, we're going to have to pass it in somewhere, so we're going to have to put it in the constructor. This is dependency injection. And then we can use our statement printer, dot print statement, and we can use our account repository, bank transactions. We've kept the method signature the same as the original example, and we have the means to print some sort of state because we passed it in to this inner layer of the statement printer. From this inner layer, or this collaborator's bank transactions of account repository. Let's just ensure we actually compile by introducing the statement printer up here. And let's run the test. And we can see that this test passes. So let's commit at this point here. And that concludes the outside loop. Now, if you were to run this for realsies, you would note that all of these methods, all these methods don't go anywhere. There's no real implementation. So the program just basically can't be run at the moment. And that's fine, because we're just basically defining a design that we're then going to implement the details of for each of these collaborators. So join me in part 2, where we'll go through the inside loop and defining out each of these collaborators and what they're supposed to do or look like. You join me in part 2, and we are now going to be defining the inside of the collaborators of our account service. First off, I think we should do a quick little refactor, and the quick little refactors in question, we can of course make this an expression body. This is an IDE refactor, we don't need to overly worry ourselves. And of course, the other thing would make sense to do is to pop these into their own class files. So let's do that. We can go into controllers and we can make an account service and then pop this in and then create a namespace around it. If you are copying at home, don't feel that you need to use namespaces. Choose to. The project honestly isn't big enough to be worrying about such things. So I'm just going to import 2 parts here, the statement printer and system, because we haven't moved account repository yet. So once I've moved that, I will then include it. So this is going to live in a new folder of repositories. Oops, I put that in controllers. Let me just move that out of controllers. and new file I account. Now, it's important to note at this point that in our previous defining the outside, that we are depending upon abstraction, and this is the this is part of solid. Let me try and think which one it is. It's a little bit of the L in solid. We don't want to have parts of our interface that aren't being used, and that's part of us just writing clean code. So we're kind of implicitly doing that one. It's also part of our dependency inversion. We want to depend basically upon abstractions and not concrete types. So this approach of using interfaces and through dependency injection just kind of ensures that's the case, and allows our mocking library to override the type, so it can do its reflection to check if the collaborator called all the things that we expected to call. So I'm just basically tidying everything up now in this quick little refactor I'm doing where I just move some stuff into some new files, and I think everything's happy. Okay, let me just run the tests to ensure that's the case. I expect 7 green tests. It would be embarrassing if one of these failed, wouldn't it? And lucky me, we didn't have any compilation errors. I moved everything and all is fine and dandy. So let's start defining the inside. We can forget about the account service now, and we can basically worry about this iAccount repository. That would seem a good place to go. It also would make sense to put some folders of where things are going to be. Let me just put this in here. Tests you also want to organize into folders if you can help it. Just give that. Get rid of these unnecessary usings. This is all IDE refactors, so again, we're pretty confident. And I'm going to make a new folder in here, and I'm going to call it repositories. And in repositories, I'm going to make the account repository should. I'm going to give it a namespace. I'm going to give it a class. And I'm still using the macros for sheer speed, and we're going to define what an account repository does. What does an account repository do? Well, we can see it makes deposits and it makes withdrawals. That's its 2 functionalities, that's its 2 behaviors, and we test behaviors. We don't need to test things that aren't behaviors. So let's define those behaviors in our skeleton like before. Deposit, withdraw, and we're going to add one other test. And this other test we're going to add is called acceptance. Now, an acceptance test is basically just a test that is going to check a flow, a couple of things running one after the other. And you'll see why we're going to need this test in a moment. Basically, it's to do with the repository, in-memory repository, retaining state. Okay. So our deposit is going to use our account repository. It's always a good place to start. Let's define iAccount repository, and let's just make a new instance in line. So that's close enough. do that, and I'm happy. And then when we generate the type, like before, it will have our interface already defined here, which is great because then we can just do one simple little addition and all is fine. Another thing we might want to do is just test that the account repository constructs, right? And when the first thing we want, sorry, we just want to test. So I would say this might be a reasonably valid first test. Now, it's not necessarily testing a behavior, but we do want to make sure that we don't have an empty, when we first initialize our account repository, that we have an empty list of bank transactions. Otherwise, we will have null there. Some would argue this isn't a valid test because it doesn't test behaviors. I'll leave that up to you. I'm putting it in just so you are aware that this is a test some people might write. I'm not saying that it's right or wrong. I'm just telling you that this is a test. So if we run the tests, and we'll see, that it's not implemented and we wanted it to be empty. So we can commit this and then we can go down and we can basically declare it like so and run the test to check that basically we have a list that we can assign to. You might not bother with this as a test. It's entirely up to you. With that being said, let's get stuck in with the deposit. So we're going to want to create a test for deposit. And you might consider that the bank transactions are covered with a assert not empty. That's another perfectly valid way of doing it. So it's entirely up to you. You might even write the test just to prove it at some point, and once it's no longer needed because it's covered in other tests, you might remove a test, right, as part of a refactor step. That's also valid. It's entirely up to you, as I said, and your decision making. So let's define something in here, an account repository deposit, right, and let's give it stuff we'd expect in here. So an amount, let's make it equal to 2. Let's give it a date time. Dates equal to date time now. And let's put an amount and a date in here. And let's also create something called an expected amount and assert equal that. Now this is a side effect test, so we're going to expect the expected amount versus the account repository bank transactions 0.amount. I'm going to generate a read-only property. And that has generated the wrong type because it's clever like that. I'm just going to pin that so I have something I can use. The balance is another thing we're going to need. The balance would also be 2. So I'll put this in here. That is my expected balance. And you know what, I'm going to call it expected balance just to make it very clear. This is how I intend to use this variable and how I intend to use this one, which I think, I think I changed that in the, didn't do that in the service as well. Oops. Whoops. Stop butterfingering around here. Let me just go to account service should and yes. Okay, cool. The expected balance to a balance, and again we need to just define this, and we might as well define the date time dates whilst we're in here, with a capital of course, which you can fix name violations with your IDE in case you weren't aware of that. And as a result, I can now just add the date here and the expected date here as well. Let's have a look. So what I'm saying is, with an amount of 2, I expect 2. With a balance of 2, I expect the balance to be set to 2. I expect the date time to be the date time. And I expect it to basically add it to this banking transactions as an amount. So let's run the test and see what we get. And it was a not implemented exception, which is fine, perfect. And what we can do here is start to define everything. So we need an internally tracked state of balance. Let's define it. Always a good idea to define it. And then balance plus equals amount. And bank transactions dot add. You could use a first class collection for bank transactions, but I can't be bothered personally. I think that's probably a bit overkill for what we're needing here. But you could define what you're going to allow the list to do. But I think this is covered in the tests, so yeah, I find it a little bit unnecessary. So let's just keep rolling what we've got. And the bank transactions, we're going to add a new bank transaction. Now we don't have this defined, but this isn't going to have any behavior on it, so we don't need to worry ourselves right now. It will only assign things, so we could write a test after it, and that's where things kind of get a little bit tricky, because then you're having to drive out all this extra stuff. But in this case, we're literally just generating an object, so it doesn't matter. So amount, balance, date, and it's just, as I say, it's just assigning stuff. So we're going to generate a class, and the bank transaction interface can be implemented, and let's make this public, and let's make a constructor with CTOR and define, sorry, Don't have to do it there. I can do it from here. Generate constructor with fields. Oh, sorry. Generate constructor with properties even. And it should... Oh, it's created duplicates, but we can get rid of these. Change the names of each of these. Okay, so the better way of to done that with the IDE, if we were to play IDE Golf, would have been to have generated it from the constructor I defined in my code rather than from the interface and then the constructor. So little lesson learned, but there you go. And we can then run tests, I think. And do you know what? It doesn't matter. If it's red, we just keep going into the screen, right? We don't have to think about these overly complicated things. And we can commit now because we have a passing step. Now, I appreciate that that took a little bit longer to get to green than normal. But that's sometimes part of the process. And it's thinking your way through it until you can get to green. So that's what we've done for deposit. Now, is there any meaningful refactors we can do? Honestly, not overly in the actual code, but at least in the testing logic, we could always add a assertion that our account repository bank transactions isn't empty, and then we don't need this test. It's now redundant, so we can remove it. The other thing we could do is we could define a theory here. But before we do that, let's run the tests just to ensure that everything still passes. Okay, that just took a little while to save. That's all that was. And in here, we can add in an amount, an expected amount, expected balance, and we can leave date time now because it's going to be basically our constant. And we can do it in. I wish upon a fish that this suggestions wouldn't cover what I'm actually writing. It would make my life a little bit easier. But nevertheless, this is a refactor step I think that we have concluded, so we can run the test again and commit, and then we can triangulate and ensure that if we were to put 5 in, then we'd expect 5 with 5, and 10 in, we'd expect 10 with 10, and so on. We don't need to go crazy, just 3, the golden number, as I was talking about before. So we can run the tests. And now we have more passing tests. We have 2 more passing tests, which is fine, so we can commit that. It doesn't challenge any of our beliefs. What about if we were to put in a negative value? What would happen then? Well, I would expect an amount of 0 and a balance of 0. Because to put in a negative deposit would mean you would be making a withdrawal, and we don't want to allow that behaviour. you might want to throw an exception in this case, in which case you would write deposit of a negative number throws an exception, right? Or something to that sort of like along that lines, and create a response test around that. I'm going to go with a default. I think that's valid. There's nothing in the requirements that says we need to throw exceptions. I'm just doing this for a little bit of a bonus, handling some of those edge cases. Some people also like to take the sad path first and consider what could go wrong and then implement how it should work. And I don't think that's an invalid approach whatsoever. I actually think that's one of the things that test-driven development unlocks, is this forethought as to how your interfaces should look and work and kind of be composed together up front. So this -10 is causing us an issue because it's not responding in the way we expect it to. Of course, we have no balance, which is fine. So we need to generate some sort of condition here. Let's say if amount is less than 0, then we need to assign amount to 0 and then add our bank transaction. Otherwise, let's do some other step, right? The default step. And I've gone with an obvious implementation here, right? And you can see that that test now passes, so we can commit. Did we not commit before? We might not have committed before. Obviously, commit the failing test and then commit the passing test, as I was implying all the way through this video so successfully. I'm not sure if I actually did that on that particular one, but I'm trying to demonstrate best practices as much as possible. Now we're on to the refactor step. So is there any meaningful refactor we could make here? Well, of course there is, and we can do it with confidence because of the test-driven development approach. And what we can do is we can move this line and the else that surrounds it. And then we can run .NET test to prove it still works. Hopefully. And it does. So that's now our refactor step committed. And the other thing we can do is give ourselves some confidence by adding a few other cases. So we might want -2 and we might want -5 as an example. To again triangulate and ensure our solution does real things. Give ourselves that confidence. Now we can take all of this data and stick it straight above our withdrawal test because it has a similar behavior and a similar method signature. And I've just taken basically everything down in the exact same way, quite honestly. Oops, let's just get over here. And the only thing we need to change is that we're now making a withdrawal, because withdraw, as you'd expect. And the numbers are going to be a little bit different. The expected amount will be negative, 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 and a negative amount in here would be 0 and 0 because we've got, yeah, I think that makes sense to me. I'm just going to comment these 3 out, and the reason I'm going to do that is because I want to drive out one behavior at a time. So even though we have a pattern, I just want to drive one behavior out at a time just to give myself a little bit more simplicity to keep that red-green refactor going at a comfortable pace, not a breakneck pace. I want correctness over sheer speed. So I'm going to run the test. I'll have 3 failing tests, but remember we have an established pattern, and we can bend the rules slightly when we have an established pattern because we're not going to spend forever in the red. The method was not implemented with the no implementation exception 3 times. It's what I'm expecting, it's what I've got, so I'm going to commit this. And I'm then going to make my implementation. And I'm actually just going to straight copy these lines because, again, speed. This is a reasonable approach, right? We don't want to have duplicate code, but at the same time, like too much of it, but at the same time, not too many duplicates is okay, and some general speed makes some sense. So with that, let's run the tests and check that we have everything passing. And we don't because we haven't changed the test correctly. Or something. Values differ. That would make sense. We'd need to make the amount negative as we add it in here, I think. I think that's the behavior we want. Because there's no, the bank transaction's not defined as a withdrawal or a deposit, so that would make sense to me. Going to commit that step. That's it passing. There's no meaningful refactor I can do at the moment, so I'm just going to move straight into the next step, which is negative, the next part of the feature, which is the negative number going in, which would of course make a deposit, and we don't want a deposit, so let's ensure that we don't have such a case. So let's run the test. And I'm using new shell with something called Starship on top of it, and it gives you these nice little symbols that lets you know if you're running like for Git basically, and an exclamation mark means you've got uncommitted features, and there's a bunch of other stuff, and I really like it. So what's gone on here? Yeah, so we've made deposits and we didn't want to, so we've got a valid test basically to work from. So again, if amount is less than 0, let's set amount to 0. Well, we have a duplicate in our code, so let's see if this works first. It does. And now we can do a refactor step, and we can extract a method, and we can call this something like check amount. And whilst it might be private, it is covered by our public interface, so we don't need to worry about testing this private method because it is covered in our tests, if you can believe it. I'm just going to copy this line down and then I just remove the other line, run the tests. Should have 19 passing tests like before. And we do, so I'm going to commit that. And then I'm going to write my acceptance test. Now my acceptance test will be a fact. You don't want to run too many acceptance tests. And what I'm going to do is basically have something very similar to this. And I'm just going to simplify the name a little bit. So amount 1. This is a little thing you can do in C#. I've never done parameters like this. I always do them like this, personally. So that's a thing, and date time. Date equals date time now the point of an acceptance test is not to test all the different variations. It's to test a general positive flow, maybe one positive, one negative flow, right? Nothing more than that. Or maybe a positive and a negative all in one place. So in this case, I'm just simply going to do positive just because I'm laying out an example. So that's what I expect for amount balance 1. Just leave myself some meaningful space. Some people don't like to leave spaces in their give and when then steps. I don't have an issue with that. I think it's perfectly valid as an approach. It makes it more readable. Anything that makes code more readable is fair enough in my opinion. We can then use our account repository to make a deposit of amount 1 with a date, and we could make a withdrawal with amount 2 and a date, and we can then assert not empty account repository bank transactions. We can basically check amount 1 account repository bank transactions 0 amount, and I just copied a couple of lines to make my life a little bit easier. I can then check balance 1 against balance and date against dates. And I can take all of these lines again, and I can do the same with these two. Change the index to 1, so I'm accessing the second part. And important note, we haven't used the for loop, we haven't used indentation here. We want to keep our tests with no if conditions and no for loops. I've said it in the previous video and I'm repeating it here. We want a straight line all the way down, 0, 0, 0, 1, 1, 1. This is a perfectly valid way of doing it. A for loop, you've got a level of indentation, and it's honestly hard to know which bit failed. When you get your error back, you know, oh, line 78 failed. You then comment line 78 out, check if any of the other assertions fail, and go from there, right? Okay, so that's my acceptance test. That's what I expect to happen. We're basically going to make a deposit of 1,000 with a balance of 1,000 and the date of now. The amount 2 with 250, that's a withdrawal with the date of now, and the balance would therefore be 750. That's what I am stating should happen. That's my acceptance test. You might want to do the best of like 3, but I'm going for speed here. Okay, the actual value was -250, and that is what I put. So let's do that. I do expect that to be the case. It's not that I'm writing my tests just to make my test pass. That's actually, I forgot I actually put it as a minus because we made a withdrawal, right? So as it goes in, it's a positive number, but as you print it out, it's the negative number as you'd expect. So let's run that again. And you can see that we now have 20 passing tests, which is great. Now all that's left for us to do is basically implement our statement printer. Now the statement printer you can't test. It's the UI, it's the bound. So what I've done is blue peated it and prepared one from earlier, and I'm just gonna uncomment that now. And I've just got to make a few changes. And all is well with the world. Whoops. Now I'm going to zoom this out. How much further do I need to go? Yes, you can see everything there. Okay, so I'm going to zoom this out. I'm using a library called Spectre Console, and you can see all the usings I'm using above. I'm just going to scroll down a little bit so you can. Whoops, not that much. That much. I'm going to just leave this on the screen for a brief moment. Do take a note of all the bits and bobs I'm doing here. Basically, I'm creating a table, and in that table I return a table with a title of account, 3 columns that I add to it, date, amount and balance, return that table. Then I write the rows from my list and basically mutate the table. And for each transaction, I am basically adding a row of transactions to array, and then each sort of comma here is a new part, and they can says use the next column basically. So that's what I'm doing here. I've got a date, amount and a balance going in, and I think this is a reverse for loop. In other words, they go in backwards, so we get the last result on the top. So that's just a little walkthrough of that. And program. The acid test is that I basically wrote this program in the same way as last time. My goodness, I am blind. I can barely see what I'm doing. Let me zoom in. Oh yes. There's one final thing I need to do, and that is to move my account repository out of this test class and the bank transaction as well. So I'm just going to do that, and in theory, all should be fine. I mean, yes, I'm going to spend about 5-10 minutes in the red, but I am also explaining things as I go. So I mean, it's not like I couldn't do this quicker. So let me just pop this away in here. account repository, namespace, class. And I'm just going to move the other one, and then I'm going to do the implementation of the using statements. And so just grab this. I think we're in models. There's a good reason I've called it bank transaction. Turns out that C# has something called transaction as an inbuilt library. So that normally I would just call it transaction because we're in the domain of a bank and a bank account. But in this case, I just wanted to ensure that when I'm importing things, that it import the right one, and I didn't want all that hassle. I wanted my demo to be as slick as I could make it, so that's just the reason I've kind of more verbosely named it than I otherwise would have. So I hope you can forgive me. Okay, account repository, and we're just going to use that, and use that, and therefore all is well. Even got the program all happy. I can run my tests. And I can commit, and I can go into banking the actual application, give it a run. And in theory, everything should be valid as we expect. So everything is being done on the 16th of December 2024. The time is nearly 2 in the morning. Don't judge me, I'm weird. And you can see that we have an amount going in of 500, and then an amount being deposited of 1,000, and then a withdrawal of 250. So our bank balance, the latest one at the top, is it's 1,250 of a currency of your choosing. That concludes the inside loop of the banking Kata. I hope this demo was coherent and that you could follow along. Hopefully I'll have some other video out on some other topic in the short term future. And with that, thank you very much for watching.